Hey guys, today we're going to be talking about triangle congruence a little bit more, and you're going to be learning about the SSS and SAS theorems, and you're going to use those to prove that triangles are congruent. Okay, so the first one that you're going to be talking about today is called the SSS property. Okay, what this suggests is that two triangles are congruent if each of the three sides are congruent. Okay, so what that means is that a triangle must have three different sets of congruent sides for it to be congruent by SSS. Okay, so each of the three sides must be congruent. Okay, so if we look at this example 1, it says we want to use SSS to explain why triangle ABC is congruent to DBC. So we want to explain why in this triangle ABC is congruent to DBC. Okay? So on this one, it suggests by our little tick marks on here that AB would be congruent to DC, or excuse me, let me start over here. Hey, if we look at our picture, we know that AC is congruent to DC. Okay, so let's zoom in on this. That AC is congruent to DC. Okay, so these two segments. Okay, and we also know that AB is congruent to BD. Okay, we can say all this because it's information that's been given to us. We can see it by our tick marks on here. Okay, so since we have those, we know all this information was given to us. It's nothing that we had to know. Okay, so the second part, we can go ahead and say that BC is actually congruent to each other. Okay, so we know that BC is actually congruent to itself. Well, why can we say that? What property? Well, we know that because of the reflexive property. We always know that something is congruent to itself. So the reflexive property of equality. Okay? Or the reflexive property of congruence, excuse me. Okay? So since you have three sets of congruent sides, we know that triangle ABC is going to be congruent to triangle DBC by SSS. Okay, we have three sets of congruent sides, so we know that those two triangles are in fact congruent. Okay, let's try one more here. We're going to use SSS again to explain why ABC, this guy, is going to be congruent to CDA, this guy. Okay, so if we go ahead and look at our information that we've been given about sides that are congruent, we can go ahead and assume that AB, this guy right here, is congruent to DC, because the tick marks would suggest that, and we also know that AD would be congruent to BC because they both have two tick marks. They're congruent. And we know all this because it was given information. Okay? And lastly, we need to find that third set of congruent sides. Well, we know that these two have a shared side, so we know that AC is going to be congruent to AC because of the reflexive property. Okay, and because of that, we know that this is our third set of congruent sides, so we know that triangle ABC is going to be congruent to triangle CDA by side property. Okay, so if you have three sets of congruent sides, you know that you're going to have a side property triangle. Okay, a term that you need to know. Okay, it's called an included angle. So go ahead and write. I'm going to go ahead and zoom in here so we can have some more room to write. Okay, go ahead and write down included angle. Okay, and I want you to write the following definition. Okay, an included angle is an angle formed by two adjacent sides of a polygon. Okay, an included angle is an angle formed by two adjacent sides of a polygon. Okay, so if you look at the picture right here of this triangle, we look at angle B, this guy right here. It is going to be an included angle between AB and BC. Okay? Now here in a second, we're going to be talking about the SAS theorem. Okay, and what SAS says is that to have two triangles be congruent, you have to have two sets of congruent sides, okay, but each of those triangles has to have an included angle between those congruent sides. Okay, so for example, you could have a triangle and another triangle, okay, and they have one set of congruent sides, two sets of congruent sides, okay, but they also must have an included angle or a congruent angle between those two sets of congruent sides. Okay, so these triangles would be congruent by SAS. They must have two congruent sides with an included congruent side in the middle of them. Okay, so let's look at this example right here. It says the diagram shows part of the support structure for a tower. We want to use SAS to explain why triangle XYZ is congruent to VWZ. Okay, so let's go ahead and look at what we've been given. We know that segment XZ is going to be congruent to VZ of the other triangle because that's been given to us. And we also know that WZ is going to be congruent to YZ. Okay, all of this stuff has been given to us based on our tick marks here. We know that those pieces are congruent. Okay, so now that we know that we have two sets of congruent sides, okay, we need to find that included angle. Well, how are we going to find it? Well, we can see right here on this triangle that these two angles are going to be congruent, and they are in between our two sets of congruent sides for both triangles. Okay, but why are they congruent? Okay, well, we can say that angle XZY is congruent, XZY is this guy, is congruent to angle VZW, this guy, okay, because they are vertical angles. Okay, so since you have two sets of congruent sides and an included angle in both triangles, we know that triangle XYZ is congruent to triangle VWZ by SAS. All right, let's try one more of these. Okay, remember SAS, we're wanting two sets of congruent sides and we're wanting one included angle for each triangle. Okay, so let's see what we have. We know that AB is going to be congruent to BD, or DB, excuse me, either way works. AB is congruent to DB, and we also know that angle ABC, this guy right here, is going to be congruent to angle DBC. Okay, this angle right below him. Okay, it has those congruent marks, so we know that they're congruent. And we know all this because this information is given. Okay, we also know, since we have our one set of congruent sides and we have an included angle, we need one more set of congruent sides to prove by SAS. So we also know that this guy is going to be congruent. Okay, we know that BC is going to be congruent to BC, once again, because something is always congruent to itself by the reflexive property. Okay, so since you have all three of your qualifications, we can go ahead and say that triangle ABC is congruent to triangle DBC by SAS. Hey, I know I've thrown a lot of information at you. Okay, so if you need to take a little break and refresh yourself, that's more than fine. All right, we're going to try one more example. Hey, but before we do that, I got a joke for you. All right, here it goes. Why did the toilet paper roll down the hill? Think about it. Think about it. He wanted to get to the bottom. You like it. Okay, so we got one more example to get through. We want to show that the triangles are congruent for the given values of the variable when x equals 5. Okay, so everywhere we see an x, we're going to go ahead and plug in a 5. So the only place we see x is in this triangle, so let's go ahead and place x values in. So on this guy, we have an x. Well, we know automatically that's going to be 5. Okay, so if we redraw this triangle, okay, we know that QR is going to be 5. Okay, if we plug in to x plus 2, we know that's 5 plus 2, or 7. So we know that QP is 7. And then if we plug into 3x minus 9, you have 3 times 5 minus 9, and 3 times 5 is 15. And if we subtract out 9, we get 6 for segment RP. Okay, so if you go ahead and compare the two triangles, you can see that both sections on both triangles, QR, is going to be corresponding to NO. In both of those sections, you'll see that that segment is 5. Okay, then the hypotenuse is going to be QP and MN. Okay, well, you can see that both of their sections are 7. And then the last ones that are similar are going to be RP and MO. Well, you'll notice that both of those are 6. So all three sides are going to be congruent, so that you know that these triangles are congruent by SSS. Okay, we have 3 sets of congruent sides, so we know that they are congruent by SSS. See ya.